Good morning, everyone. Today we'll talk about irrational numbers. Lesson 2. Rational and irrational numbers. What is the meaning of irrational numbers? We take before rational number in prep 1. And today we will know the irrational numbers. Irrational numbers, any number which can't be written as a fraction. What is the meaning of irrational number in history? Please make a search on internet of the history of irrational numbers. The rational and irrational are needed together in order to compare the set of real numbers. Rational numbers. Rational numbers consist of 4.5, 27 over 4, 0.3, negative 10 over 11, negative 1, negative 3, negative 7, 0, 1, 2, 3. Irrational number here, it's all number that we can written as a fraction. Now we will find negative 1 with negative 3 with negative 7 with 0, 1 with 2 with 3. It's integer number. The integer number consists of a natural number and negative number. 1, 2, 3 is called counting number. As we know, an irrational number, that any number we can't written as fraction, like root 17, root 2, e by negative 11. Reading math. Q, it's a symbol of the set of rational numbers. Q dash equal the irrational numbers. Z, it's the symbol of the set of integer numbers. N is a symbol of the natural numbers. C is the symbols of the counting numbers. Rational and irrational numbers. At the first, rational numbers A over B. We said before, rational number, it's all number that we can written it as a fraction. For example, 4 over 5, it's a rational number because it's like a form, A over B. 2 over 2 and 2 over 3 equal 8 over 3. We can convert a mixed number here as a fraction. So it's a rational number. Another example. Negative 6. Negative 6 here, it's a rational number. Why? Because we convert it as a fraction. Write all classification that apply to each number. Letter A, 7 and 4 over 9. 7, 4 over 9 can be written in the form A over B. Yes, we can write it in the form A over B. It's equal 67 over 9. So it's a rational number. Letter B, negative 12. Negative 12 can be written in the form A over B. Yes, it will be negative 12 over 1. So it's rational number and integer number. Another example. Root 10. Root 10 is not a perfect square, so root 10 is irrational number. Letter D, cubic root 2. 2 is not a perfect cube root, so cube root 2 is irrational number. Letter E, 3 plus 11. is not a perfect cube root, so it's irrational number. Determine the following are rational or irrational. Letter A, 0.73. Yes, rational. B, root 2. Irrational. Letter C, 0.6666 and so on. Rational. Letter D, 3.142. Rational. Letter E, root 12.25. Irrational. F, root 7. Irrational. Letter G, 4 plus root 5. Irrational. H, cubic root 2 all power 3 plus 1. Rational. I, 16. Rational. J, cubic root 2 all power 2. Irrational. If x belongs to Q dash, find the solution set of H equation. X power 3 equal 5. Solution. We will take a cube root for the both sides, so the solution set equal cubic root 5, and cubic root 5 belongs to Q dash. It's irrational number. Another example, 2 over 3 x power 2 equal 5 over 7. Solution. X power 2 equal 5 over 7 divided 2 over 3 by x power 2 equal 15 over 14. Now we will take a root for the both sides. So x will be positive or negative root 15 over 14. We will find in root 15 over 14 belong to Q dash, so the solution set equal positive or negative 15 root 15 over 14. Prove that root 6 lies between 2.1 and 2.5. Solution. Since in the root 6 equal 2.449 and so on, therefore in 2.1 smaller than 2.4 smaller than 2.5, therefore 2.1 smaller than root 6 smaller than 2.5. Or we will make a power for all sides. We will find in 4.41 smaller than 6, with 6 smaller than 6.25. So in root 6 between 2.1 and 2.5. Lesson quiz. Find number 1 root 9, number 2 negative root 1 over 81, number 3 cubic root 125, number 4 fourth cube 1, number 5 find the approximate value of the to the nearest tens, root 8 and cubic root 15. Write all classifications that apply to each number. 6 negative 3.897 root 500. The result of number 1 equals 3. Number 2 negative 1 over 9. Number 3 5. Number 4 1. The result of question number 5 2.8 and 2.5. The result of question 6 rational recurring decimal. the result of question number 7, irrational number.